Hello dear students. Now just I will take a revision class for linear programming problem. Solving linear programming problem was a very important topic. From this topic maybe 5 marks questions is asked in your exam. So just here this year just unbounded condition is out of syllabus, but unbounded condition is also important. Just we have to solve all the questions which are bounded, but unbounded is simple difference for solving unbounded problem. So take this right problem. Okay, we have to understand how can we solve right problems by using linear programming problem. Okay, question is, a dietitian wishes to mix two types of foods in such a way that the vitamin contents of mixture contains at least 8 units of vitamin A and 10 units of vitamin C. Food 1 contains 2 units per kg of vitamin A food and 1 unit per kg of vitamin C food. C. Okay. So vitamin A and C. So here, while food 2 contains 1 unit per kg vitamin A and 2 units per kg vitamin C. It costs rupees 5 per kg to purchase food 1 per kg food 1 5 rupees and 7 per kg food 2. Okay, so determine the minimum cost of such a mixture just by mixing two types of food. Food contents, we dietitian wishes to make food by mixing two types of contents, and we have to formulate LPP and solving it graphically. Okay, so here this type of question, say two types of food and its quantity are given and minimum requirement also given, so we can prepare table for writing constraints. We know constraints because here we have to write a formulate first. Just suppose x kg food 1 and y kg food 2 is required, and what is the given condition, just condition can be written in a tabular form, then we can write constraints, that is inequality, and then just we can say that this is minimized by using these constraints. Okay, so here take its solution. We can write given information as, just we can write in tabular form. Okay, so what vitamins? First here vitamins A and C. Vitamins what? Vitamin A, vitamin C, we can make a table. Just like this. Vitamins, vitamin A and vitamin C. Cost. Rupees per kg. Okay, we can write cost rupees per kg. And here, just food 1, food 2. Okay. So what is given? Food 1. Food 1. Food 2. And here it is at least, that is minimum requirement. At least means requirement. Okay. So where we see that what at least 8 and 10 units. Vitamin A 8. Vitamin C 10. In question. Okay. And 2, 1, and this is 1 and 2. This is 2 kg of food. Here, food 1 contains 2 kg vitamin A. Food 1 contains 2 kg vitamin A and 1 kg vitamin food 2 and 1 kg vitamin C. Similarly, food 2, 1 kg and 2 kg. And this is requirement. Okay, this is at least requirement. And cost is also given. Food 1 5 and 7 rupees. 5 rupees and 7 rupees. From this information we can write our formulation for LPP. So let food 1 x kg. Okay, so let the amount of food 1 be x kg and the amount of food 2 be y kg, x kg and y kg. Okay, and cost this and the total cost denotes is denoted by total cost is denoted by Z. Total cost is denoted by Z. Amount of food 1 x kg, food 2 y kg. The total cost is denoted by Z. Then we can write Z equals to what? Total cost. X kg food. So cost 5x, 5 rupees, x kg, 5x kg and 7y kg. 5x plus 7. Okay, this is cost function, objective function. We are trying to this objective function either maximize or minimize. Here, cost is for maximize. Just we have to minimize this value of Z. Okay, and also constants. So constants, what is the given? This and just x kg. So 2x plus 1y is at least 8, so greater than 8. 2x plus y is greater than 8. Okay, just greater than equal. We can write greater than equal. X plus 2y, y, x plus 2 into y. This is x kg, so x into 1, x plus 2 into y is greater than 10. Is greater than equal 10. Also our non-negativity condition, we get this type of inequalities. This is greater than equal 8, this is greater than equal 10, this is greater than equal 0, this is greater than x kg. Kg should be something, so greater than equal 0. So this is non-negative condition. These 4 are called constraints. This is called objective function. Now our formulation will be what? We have to minimize this. So our formulation will be what? So our LPP formulation will be as follows. Minimize z equals to 5x plus 7y. 5x plus 7y. Subject to the constraints. Subject to the constraints, this 3x plus greater than equal 8, x plus 2 is greater than equal 10, x is greater than equal 0, y is greater than equal 0. So this is our formulation. So our LPP formulation will be as follows: minimize this, subject to the constraints, this. These are called constraints. This objective function we have to minimize here. Minimum cost is minimum, have to minimize. So this is formulation. Now solving graphically. For solving graphically, just we will draw straight line. Here less greater than equal, greater than equal. So we have to draw bold line, not dotted. If strictly greater than or strictly less than, then just we have to draw dotted line, and that points are not in the region, physical region. So just for graphical solution of this, we have to draw a straight line by taking inequalities one by one. So this is non-negative condition. We know in the first quadrant, just because x is greater than or equal to 0, that is upper side, sorry, right side, and y is greater than or equal to upper side. So first quadrant, our diagram will be in the first quadrant here. Now the result will be, now to minimize z, we have to first draw feasible reason for this LPP. Okay. For this, take first constraints, just take as a straight line. First take 2x plus y is greater than or equal to 8. Clear? This. Here we see that just by taking this we can get straight line, and for drawing a straight line we require 2 points. So take 2 points on this straight line, value of x, value of y. Okay, so first value 0, then 0. Just this is easiest value. If x equal to 0 here, then y equals to 8. If y equals to 0 here, then x equals to 4. So this is our tabular form. This is point A, this is point B for this first straight line. Okay, this is first straight line. Also, take second, x plus 2y. X plus 2y equals to 10. 2. Second straight line. Here. You see that. Just make a table. Just you have to get what? 2 points on the straight line. So you can write like this. Suppose this is x, this is y. Take it 0, also it's 0. Because on the one point is on x-axis and one point is in y-axis. So x equal to 0, so y equals to 5. And y equals to 0, x equals to 10. This is point C, this is point D. Suppose. Now we have to draw to a straight line. First straight line, second straight line. Okay, so this is our, and x is greater than equal, y is greater than equal. That is very simple for drawing. Okay, so draw a straight line. First of all, we draw y-axis. This is y dash. This is y-axis and this is x-axis. Suppose this is x-axis. This is origin 0. And here our range value, the range of the, because we have to take scale. So here highest value is 10. So we can write like this. This is suppose 2, 4, 6, 8, 10. So this is 1, 3, 5, 7. We can write 9. Just take this scale. So here also 2, 4. The value of y ranges from 8. 2, 4, 6 and 8. Okay. So this is 2, 4, 6, 8. This is 1, 3, 5, 7. Similar value we can take either -2, -4, -2, -4. Just draw the scale. Now we have to draw first straight line. A point 0, 8. 0, 8. This is x equal to 0. So 0, 8 is this. This is A. A. Y-axis. This is A. 0, 8. And B 40. This is 40. Okay, this is 40. So it is 40. Here B point. It is point B. Now draw this straight line. This straight line is 2x plus y equal to 8. 2x plus y equals to 8. And for graphical solution, just we see its inequality. Its inequality means greater than equal 8. That means its solution in which side? Because it comes from where? For this 2x plus y is greater than equal 8. So this inequality will satisfy x equal to 0, y equal to 0, 0 is greater than equal 8, not satisfied. So in this side will be solution. So this side will show the solution. That is, this side is solution points. Okay, for this. Similarly, here is also greater than equal. So for drawing this sheet 0, 5. So this is 0, 5. This is 0, and this 5 is here. This is 0, 5. 0, 5. 0, 5. Point C. And 10, 0. This 10, 0. This is D, point D. Now draw this line. Okay. So this is the line C, this point C. This line to x plus 2y equal to 10. X plus 2y equals to 10. And also here x plus 2y is greater than or equals to 10. Origin not satisfied. So solution will be in which side? This side. This side. Upper side. Okay. In this side and in this side, that is this portion. Clear? Now, our shaded region. Here x is greater than or equal to 0. Also, x is greater than or equal to 0. That is, this is x is greater than or equal to 0. That means this side. This side. And y is greater than or equal to 0. That means this side. This side. That is in this part. So this is our region. This is the region. Okay, here no boundary is there. That is unbounded region. Unbounded unbounded physical region. Unbounded region. This physical region is unbounded. Unbounded physical region. Physical region is unbounded. Okay. Now, intersection point is this. Okay. Suppose this is point E, and its intersection can be found we can find by solving these two. Solving 1 and 2. Solving 1 and 2. One and 2, we get what? X just multiply it by 2, then 4x plus 2y, y cancel, 16 minus 10, 6, so 4x, 5x, 16. So here this common point is 2 and 4. Let's solve it. What? By multiplying it by 2, 4x plus 2y equals to 16 minus x minus 2y equals to 10, 6 and 3x, 6 means x equals to 2 and y equals to x equals to 2 and y equals to 4, 2 and 4, x equals to 2, y equals to 4. That is our point E, 2, 4. 2, 4. 2, 4. Okay. So just intersection point you have to also find. Suppose this is E and solving this two equation, we can get 2, 4. Okay, point 2, 4. Now, the feasible region is shaded in this figure. Just after this stage, our procedure is what? Just find corner points. Visible region is shown as following figure. Clear? Visible region. And this. The corner points, just our target is what? Corner points. So corner points is what? A, E, D is corner point. The corner point points of and the corner points of visible region are A 08, E 24 and B 10, 0. These are the corner points. And so the values of Z at these points are, just write what? Corner points. We have to write corner points A 08, E 24, D 10. Value of Z equals to 5x plus 7y. just put the value of 0, 8 here. So 0 means 0 or 7 or 8, 56. So what is the value of 56? 38. Just see. 10 has 38, and this is what? 56, 38 and 50. Here you can see 10, 0, 50. Corresponding value. Its corresponding value this, its corresponding value this, its corresponding. Just calculate the value. X equal to y equal to x equal to 0, 8, y equal to 8, x equal to 2, y equal to 4, x equal to 10, y equal to 0. Put here and just find the value. This is minimum. It is not required now, it is minimum value. Since we have to write unbounded region, because in the case of unbounded region, you can get here values 56, 38, 50. Here we see that 38 is minimum, but it may be minimum or may not be minimum value. For deciding whether it is minimum or not, we have to draw another straight line of which solution have no common point, then it will be minimum or maximum. So here, since feasible region is unbounded, since feasible region is unbounded, therefore the value 38 may or may not be the minimum value. May or may not be the minimum value. And for this, we have to draw another inequality, solution of inequality. We have to draw the graph for the inequality for the inequality. Just take z equals to 5x plus 7y is less than 38. Z. Therefore, the value z equals to may or may not be the, so z equals to 5x plus 7y is less than 38. Just we have to draw its graph, and if its solution have no common point with this, then we can say it is minimum. If have some common point, then we cannot decide. Clear? Similarly as for maximum case. If for maximum, then just take here greater than. Here minimum, so take less than 38. For this, take 5x plus 7y equals to 38. Third straight line. Just prepare it. Value table for xy. Okay. X, y, take its value 0, take its value 0. If we take x equal to 0 here, then y equals to 38 by 7. 38 by 7. 38 by 7. 38 by 7, 5.4. Just we can write it 5.4. 5.4. If y equals to 0, then 38 by 5. X equal to 38 by 5. 38 by 5. So 38 by 5 can be put 7.6. 7.6. Just like this value. Okay. This is the value 7.6. Now our point is what? A B C D E F, and we can see that 0 5.4. What is 0 5.4? This is 0 and this is 5.4. Maybe here point. This. Okay. So this is the point. Suppose P point is this. Similarly, this is P point. Yeah, Q point. 7.6 is 0. 7.6. This is 7.6. This is point Q. 7.60, or this is point 5.0, 5.4. Now draw the graph of this line. So just we see this. This is the graph of this inequality, and here we see that 0 0 origin 0 less than 38, right? That is, its solution is in this side. Its solution is in this side. Now this side does not contain any value of this reason. So we can write have no common point. From graph of line PQ, that is Z less than 38. It is clear that it has no common point. With feasible reason. Here unbounded reason, feasible reason is unbounded, and this graph of this line inequality solution have no common point with this feasible reason, with the feasible reason. Therefore we can decide, therefore the minimum value of cost function Z is 38 rupees. Okay, 38 rupees. At the point at E24, that is 2 means X. X means 2 kg of food. Amount of food 1 is 2 kg and amount of food 2 is 4 kg. That is the amount of food 1 is 2 kg and the amount of food 2 is 4 kg. Should include. You can write should include. Should be included. Should be included in the mixture. Okay, amount of food 1 is 2 kg and amount of food 2 is 4 kg. Should be included in the mixture for minimum cost. For minimum cost. ₹38 rupees. So this is our solution. ₹38. Minimum cost 38 rupees. Okay. So this is the process for finding the solution of diet problem graphically using LPP. First of all, formulate LPP and then just draw the graph and see whether region is feasible or feasible region is bounded or unbounded. If bounded, then you can direct find the maximum minimum value from preparing the table at corner points, the values of cost function at corner points. And if unbounded, then just for minimum, also draw a inequality. For maximum, yeah, you can take inequality. If have no common point, then we can decide minimum or maximum. So here have no common point, has no common point, so we can decide this is minimum. Okay. So this type of questions you have to do, and very important topic, and maybe come 5 marks questions from this chapter. So do some practice for doing diet problems and manufacturing problems. Okay, you have to do also examples are very important, and exercise also. So do some questions and send me solution of 1-2 questions for your attendance. Okay.